The universe is enormous. Trillions of galaxies, each with billions of stars, and more planets than we can count. So here's the question that should bother you. If life is everywhere, why haven't we met anyone? Hollywood tells us aliens should already be here, landing on the White House lawn, abducting farmers, or leaving secret messages on the moon. But according to theoretical physicist Michio Kaku, the truth is far more unsettling. Aliens may be real. Intelligent life may be common. And yet, meeting them could be almost impossible. Not because they don't exist, but because the universe itself may be designed to keep us apart. So what if the real mystery isn't where the aliens are, but why physics won't let us reach them? Before we go any further, we need to answer an important question. Why should we take Michio Kaku seriously when it comes to aliens? Because Kaku isn't a UFO blogger, a Hollywood screenwriter, or a conspiracy theorist chasing clicks. He's a theoretical physicist, someone whose job is to test ideas against the harshest judge of all, the laws of nature. Michio Kaku is a professor of physics and a co-founder of string field theory, a branch of physics that attempts to unify all the fundamental forces of the universe into a single mathematical framework. In simple terms, his work deals with how reality itself is built space, time, energy, and matter at the deepest levels we know how to describe. That's important because when Kaku talks about aliens, he's not speculating from imagination. He's asking a very specific question. What does physics actually allow? And here's where many people misunderstand him. Michio Kaku is not an alien denier. In fact, he has repeatedly said that given the size of the universe, the existence of extraterrestrial life is not only plausible, it's likely. With hundreds of billions of galaxies, each containing hundreds of billions of stars, it would be statistically shocking if Earth were truly alone. But believing in alien life is not the same thing as believing in alien visitors. This is where Kaku draws a sharp line. He argues that while life may be common, physical contact between civilizations is an entirely different problem, one constrained by brutal limits: distance, energy, time, and survival. Limits that don't care about optimism, belief, or eyewitness stories. In other words, Kaku's skepticism isn't emotional, it's mathematical. This video isn't about debunking aliens. It's about debunking our expectations. We've been trained by decades of science fiction to assume that advanced civilizations naturally explore the galaxy, that they visit younger worlds, and that contact is inevitable. Kaku challenges that assumption not by saying aliens aren't real, but by asking whether our ideas about them are shaped more by human psychology than by cosmic reality. So as we move forward, keep this in mind. This isn't a story about disbelief. It's a story about limits. And if Michio Kaku is right, the greatest barrier between us and alien civilizations isn't secrecy, government cover-ups, or technology we haven't discovered yet. It's the universe itself, the speed of light problem. If there is one obstacle that quietly destroys most dreams of alien contact, it's not technology, secrecy, or intelligence. It's distance. Space looks empty on a screen, but in reality, it is unimaginably vast. So vast that our brains are simply not equipped to feel how far things really are. This is where Michio Kaku says the conversation about aliens usually goes off the rails. Let's start with the fastest thing in the universe. Light travels at about 300,000 kilometers per second. That sounds incredible, and it is. Light can circle the Earth more than 7 times in a single second, but even at that speed, the universe still wins. The moon, about 1 second away at light speed. The sun, roughly 8 minutes. Now here's where things start to break down. The nearest star system to Earth, Alpha Centauri, is more than 4 light years away. That means light itself, moving at the absolute cosmic speed limit, takes over 4 years just to get there. And that's our closest neighbor. Most of the stars you see in the night sky are tens, hundreds, or thousands of light years away. Entire regions of our galaxy are separated by distances so large that even communicating across them becomes a generational project. And here's the key problem. Nothing with mass can travel at the speed of light. This isn't a technological limitation. It's a fundamental rule of reality. As an object with mass accelerates closer to light speed, its energy requirements increase toward infinity. In simple terms, no matter how advanced a civilization becomes, the universe charges an impossible toll for trying to go that fast. So what happens if we slow things down to something realistic? Let's imagine a highly advanced spacecraft, far beyond anything humans have ever built, traveling at 10% the speed of light. That's already wildly optimistic. At that speed, reaching Alpha Centauri would still take over 40 years. One way, no faster than light jumps, no shortcuts, just cruising through empty space for decades. Now stretch that problem across the galaxy. The Milky Way is about 100,000 light years across. Even traveling at near light speed, crossing it would take tens of thousands of years. At more realistic speeds, hundreds of thousands or millions. This is where Michio Kaku pushes back against science fiction. Movies and TV shows treat interstellar travel like a long flight. You board, sleep, wake up, and arrive. But physics doesn't work that way. There's no refueling station between stars, no emergency exits, no convenient pauses. Space is cold, empty, and lethal, and it stays that way for the entire journey. What about warp drives, wormholes, hyperspace? Kaku doesn't dismiss these ideas outright, but he's careful. These concepts exist on paper, inside highly speculative solutions to Einstein's equations. They often require forms of matter or energy that we've never observed, like negative energy or exotic matter. Even if such things exist, controlling them on a starship scale remains far beyond anything we can realistically imagine. In Kaku's words, faster than light travel sits at the edge of theoretical possibility, not engineering reality. And there's another problem people often forget. Traveling between stars isn't just about speed, it's about survival. Cosmic radiation, micrometeorites, mechanical failure over centuries or millennia, biological decay, psychological collapse. Even if a civilization could build a ship capable of crossing interstellar distances, keeping its occupants alive for that long becomes its own unsolved problem. And this applies to aliens too. We often assume that advanced civilizations must have solved these challenges, but Kaku warns against this assumption. Physics doesn't grant exemptions for intelligence. The same cosmic rules apply to everyone, everywhere. This leads to a disturbing conclusion. Alien civilizations could be common. They could even be technologically advanced, but they may be trapped, isolated in their own stellar neighborhoods by distances that are simply too great to overcome. From this perspective, the universe doesn't look like a bustling highway of alien traffic. It looks more like an archipelago of islands, separated by oceans so vast that most travelers never leave home. And if that's true, then the silence we observe, the lack of visitors, the absence of signals, the empty skies, may not be evidence that we're alone. It may be evidence that the universe is doing exactly what physics predicts, keeping everyone apart. Even if we could overcome the tyranny of distance, Michio Kaku reminds us that time itself is another formidable barrier. The universe isn't just vast in space, it's vast in time, and civilizations are fleeting compared to cosmic scales. Let's step back and think about humanity. Modern civilization, the one capable of sending radio waves into space, has existed for about 100 years. That's the window during which we could even hope to be detected by distant observers. A blip of activity in the 13.8 billion year history of the universe. Almost nothing. Now imagine alien civilizations. They, too, have life cycles. They rise from primitive beginnings, develop technology, and eventually either stagnate, destroy themselves, or evolve into forms we cannot even recognize. On the scale of the cosmos, these cycles are brief. Millions of years here or there are just fleeting moments. What does that mean for contact? It means that two civilizations must not only exist in the same galaxy, they must also exist at the same time. That overlap is incredibly unlikely. We could be listening to the sky right now, But maybe the closest intelligent life already vanished millions of years ago. Or perhaps advanced civilizations will only emerge millions of years in the future, long after humanity has disappeared. Kaku often uses the metaphor of ships passing in the night. Even if the galaxy is full of advanced civilizations, most of them may never encounter one another. Their paths, their timelines, simply don't intersect. Space may be crowded in potential, but empty in practical reality. Civilizations may come and go, each one oblivious to the others. This also reframes the famous Fermi paradox. Why haven't we seen alien signals? Maybe not because they aren't there, but because we are out of sync. Humanity is early, or perhaps we are just in the wrong cosmic moment to witness the galactic stage. The signals may have reached their peak millions of years ago, long before we could detect them, or may not arrive for millions of years to come. Consider Earth's own history as an example. Complex life has existed for only a few 100 million years, and technological civilization for just a fraction of that. Even if intelligent life is common, the timing window for detectable activity is extremely narrow. The odds that two civilizations with overlapping broadcast windows are close enough to detect each other? Vanishingly small. Time, in this sense, is the silent killer of cosmic encounters. Unlike distance, it cannot be bypassed with faster ships or better technology. It marches on relentlessly, indifferent to ambition or desire. A civilization that lasts a few thousand or even a few million years might appear to the universe as a brief flicker, and from other civilizations' perspectives, may as well have never existed. This perspective challenges a key assumption in popular alien lore, that intelligent life, once it emerges, will inevitably explore the galaxy and meet others. The reality is far less romantic. The universe may be teeming with life, but the chances of two civilizations existing at the same time, in proximity, and with overlapping detection windows are staggeringly slim. Kaku emphasizes that our expectations are shaped by storytelling, not by cosmic reality. Movies and novels depict civilizations as persistent, invincible, and adventurous. The universe, however, is a realm of short-lived sparks, brief lights in a vast, dark expanse. Civilizations rise, shine, and fade, often unnoticed. So while distance keeps civilizations physically apart, time ensures that even the closest stars may host civilizations that never see each other. In the grand scale of the cosmos, most intelligent life may be isolated not by barriers of space, but by barriers of time, ephemeral moments that never coincide. And this is the second nail in the coffin of casual alien contact. Not only would a civilization need to survive the journey across light years, but it would also need to exist at the exact right moment, synchronized with another life form across unimaginable expanses of both space and time. It's a sobering thought. The universe could be alive with intelligence, yet we may be destined to witness it only as ghostly echoes in the void, never interacting, never greeting, never meeting. The stars above may harbor life, but humanity's fleeting window of cosmic attention may simply miss them entirely. When we imagine aliens, we tend to picture explorers, starships launching into the void, advanced civilizations eager to colonize, communicate, or guide younger species. This, however, is a human-centric assumption, and Michio Kaku warns us it may be completely wrong. The first thing to understand is that intelligence doesn't automatically mean curiosity, expansion, or exploration. On Earth, intelligence evolved primarily as a tool for survival, not for building interstellar civilizations. Even among humans, not everyone is driven to explore beyond their immediate environment. What makes us think aliens would be any different? Kaku proposes a number of alternative priorities that an advanced civilization might pursue, priorities that are entirely inward-focused. Virtual realities. Just as humans increasingly inhabit digital worlds, aliens may have developed forms of consciousness or entertainment so immersive that they rarely, if ever, leave their home planet or star system. Entire civilizations could exist entirely in virtual spaces, rendering physical exploration unnecessary. To them, the universe might seem more like a distant background than a destination. Energy efficiency. For advanced civilizations, the cost of interstellar travel is immense. Instead of spreading outward, it may make more sense to optimize energy use, improve life on their own worlds, or construct efficient habitats rather than risk the dangers and inefficiencies of long-distance travel. The smartest civilizations may be the ones that stay home. Non-technological intelligence. Intelligence may take forms we cannot even recognize. Civilizations might exist on levels we don't detect, sentient life forms that don't emit radio signals, build starships, or display the kinds of technology humans expect. Just because a species is intelligent doesn't mean it fits our blueprint of an advanced civilization. This leads to a key insight. Our expectations are anthropocentric. We project our history onto the cosmos, the age of exploration, the Industrial Revolution, space travel, and assume that these trajectories are inevitable for all intelligent life. Kaku cautions against this projection. The universe doesn't operate according to human psychology. Civilizations may evolve along paths that make alien contact uninteresting, unnecessary, or even undesirable. For instance, imagine a civilization that has perfected its own planet, created near-perfect social systems, or developed sustainable virtual worlds. Why leave? Why travel through the dangerous, vast emptiness of space when your home system already provides everything you need? Unlike humans, aliens may not have the same curiosity or need for expansion, especially if they have overcome scarcity and survival pressures. Kaku uses this argument to dismantle one of the most persistent myths in alien lore, that technology inevitably leads to spacefaring empires. He reminds us that technology doesn't mandate exploration. The smartest or most advanced civilization might be the most static, quietly focusing inward while the galaxy continues on around them. This also explains a key aspect of the Fermi paradox. Even if life is common and intelligent life exists, the universe may remain silent simply because no one is looking outward. It isn't about hostility, conspiracy, or hiding. It's about choice and priorities. In this scenario, our cosmic loneliness isn't evidence of absence, but of divergent trajectories. Visualizing this, Kaku suggests alien civilizations could be inward-focused, like islands of consciousness, disconnected from the galactic sea. They might exist in Matrix-style realities, fully satisfied with artificial worlds, leaving no trace in the physical universe for us to detect. In short, intelligence is not equal to exploration. A civilization's sophistication may not translate to interstellar travel, communication, or curiosity. Our expectation that advanced life must eventually meet or contact us is shaped more by imagination than by physics, biology, or sociology. So when you look at the night sky, remember, even if life is abundant, it may be quiet, static, and uninterested in the universe outside its own walls. Advanced aliens might exist, yet remain effectively invisible, not because they can't be detected, but because they choose not to be. This realization shifts the conversation. The silence of space is not necessarily disappointing. It may be the natural outcome of intelligence, a universe full of conscious life that never looks up from its own worlds. As we continue exploring why meeting aliens may be almost impossible, Michio Kaku introduces a more speculative and unsettling possibility: the galactic zoo hypothesis. The idea is simple yet mind-bending. Just as humans observe uncontacted tribes in the Amazon without interfering, perhaps advanced extraterrestrial civilizations observe Earth intentionally avoiding direct contact. In other words, we might be part of a cosmic experiment, a protected world, or simply ignored until we reach a certain level of technological or social maturity. Why would civilizations do this? Kaku suggests several reasons. First, non-interference. Advanced species may understand the dangers of influencing a developing civilization. Imagine the ethical dilemma of giving a pre-industrial society advanced technology. The consequences could be catastrophic. Just like anthropologists avoid imposing themselves on isolated human cultures, aliens may choose to let humanity develop on its own timeline. Second observation for knowledge: we could be under surveillance, not for manipulation, but for study. This aligns with what scientists call the prime directive scenario, where civilizations monitor rather than interact, gathering data on evolutionary patterns, societal development, or technological progress, all without revealing themselves. Third, strategic caution. Advanced civilizations might avoid contact because any encounter could carry unpredictable risks. From their perspective, an aggressive or reckless species could spread chaos. Keeping a safe distance is a rational choice, not a matter of malice. Kaku is careful to frame this as speculation, not fact. He doesn't claim the galactic zoo hypothesis is true, but he considers it plausible within the laws of physics and sociology. After all, if civilizations are separated by vast distances and immense timescales, direct contact might be extraordinarily rare. Observing from afar could be both safer and simpler. To understand this concept, consider a human analogy. Imagine an anthropologist studying an isolated tribe in the Amazon rainforest. The anthropologist might observe for years without ever revealing their presence, allowing the tribe to develop naturally. From the tribe's perspective, the observer doesn't exist, yet they are being watched. Now scale that scenario to the galaxy. Earth may be the tribe, and alien civilizations are the distant observers, careful not to disturb the natural progression of life. This idea also offers a potential explanation for the Fermi paradox. If advanced civilizations exist but intentionally avoid contact, then the apparent silence of the galaxy isn't evidence of absence, it's a deliberate cosmic policy. The universe could be teeming with life, yet all life may be quietly respecting each other's boundaries, much like a galactic ecosystem governed by mutual restraint. Visualizing this, Kaku suggests thinking of Earth inside a cosmic enclosure, a planet under careful observation, with advanced civilizations orbiting in secrecy, surveillance-style animations, distant probes, glowing star systems monitoring signals can illustrate this concept, showing that we may be in plain sight without ever noticing. The unsettling part of this hypothesis is psychological. It challenges our sense of cosmic importance. We like to think of ourselves as central players, destined to explore the stars and meet alien neighbors. But if the galactic zoo hypothesis is accurate, our cosmic interactions are intentionally limited, and humanity may be nothing more than a species under observation, not a peer among equals. Kaku doesn't fully endorse the idea, but he remains open-minded. He emphasizes that while there is no evidence for this scenario, it's scientifically plausible and intellectually worth considering. In a universe of unimaginable size and complexity, it's dangerous to assume we know what advanced civilizations would do, or that they would act according to our expectations. In the end, the galactic zoo hypothesis adds a philosophical dimension to our search for extraterrestrial life. It suggests that silence is not always an absence, and invisibility is not always a failure. Sometimes it might be the best strategy for survival, growth, or ethical responsibility, a cosmic version of look but don't touch. If true, this could explain why humanity has seen no aliens, heard no signals, and remains alone in our night sky. The universe may not be barren, it may be polite, cautious, and far smarter than we are. Even if we grant that civilizations emerge, survive the tyranny of distance, navigate the timing of cosmic windows, and resist the temptation to remain inward-focused, Michio Kaku warns of another existential obstacle. Civilizations may destroy themselves before they ever make contact. This concept is often referred to as the Great Filter. It suggests that while intelligent life may arise relatively frequently in the universe, technological civilizations rarely survive long enough to spread across the stars. In other words, the biggest threat isn't the difficulty of space travel, but the fragility of intelligence itself. Consider humanity as an example. In just a few centuries, we've developed weapons capable of global annihilation. Nuclear arsenals can wipe out civilizations in minutes. Climate change, driven by industrial progress, threatens long-term survival. Advanced artificial intelligence, if mismanaged, could create systems beyond our control. In short, the very technology that enables a civilization to explore space also puts it at existential risk. Kaku emphasizes that this may be true for alien civilizations as well. Across the galaxy, the bright young stars of intelligent life may rise only to collapse under the weight of their own inventions. Planets could host species that briefly flourish, emitting detectable signals for a few hundred years, then vanish, leaving no trace. This could help explain the eerie silence we observe in the cosmos. The Great Filter can act at multiple stages. Perhaps most species never reach intelligence. Perhaps intelligence rarely produces advanced technology without self-destruction. Or perhaps civilizations consistently fail to survive long enough to communicate across interstellar distances. Whatever the stage, the underlying lesson is stark. Existence is precarious, and survival is far harder than discovery. Kaku stresses that technological maturity is no guarantee of survival. Creating starships is one challenge. Surviving the consequences of technology is another, often far greater. Civilizations may flourish for a brief cosmic instance before succumbing to internal or external threats, leaving no signal for the next species to detect. This idea also reframes our expectations about alien contact. We may imagine that the universe is crowded with intelligent observers waiting to meet us, but if most civilizations fail to survive, the apparent emptiness isn't a mystery, it's a natural outcome of survival bias. The universe may have been bustling with life at different points in time, yet only a few, or perhaps none, persist long enough to be detectable now. Visualizing this, imagine a civilization as a bright flare. It ignites, shines, and eventually fades into darkness. Across the galaxy, countless flares appear and vanish, with their light never intersecting another's. Red warning graphics, collapse loops, and fading cities illustrate the fragility of intelligence in Kaku's framework. The lesson is sobering. Intelligence is not destiny. Advanced technology may grant the ability to explore the stars, but without survival strategies, it may accelerate extinction rather than ensure longevity. Michio Kaku's warning is clear. The universe doesn't reward curiosity alone. It rewards resilience, foresight, and the ability to navigate existential threats. In practical terms, this perspective encourages humanity to reconsider its priorities. The focus shouldn't only be on reaching out into the cosmos, but also on safeguarding our civilization. The same principles that might doom alien species could doom us if ignored. Sustainability, risk management, and ethical development of technology are not just philosophical concerns, they are survival imperatives. Ultimately, the silence of space may be a mirror reflecting a harsh cosmic reality. Civilizations are rare not because life is impossible, but because survival is extraordinarily difficult. If Kaku is correct, the greatest barrier to meeting aliens is not the stars, the timing, or even the will of other civilizations. It's the challenge of staying alive long enough to make contact at all. Even after exploring the vast distances, fleeting windows, inward-focused intelligence, protective cosmic policies, and existential risks, one question remains: why haven't we heard or seen aliens? Michio Kaku urges us to sit with this tension. The universe may be teeming with life, yet the silence persists. And the silence itself becomes a puzzle, almost as profound as the possibility of intelligent life. First, consider the possibility that Earth is either early, late, or simply irrelevant. Humanity has existed for only a fraction of cosmic history, and our technological window is minuscule. Perhaps we are a fledgling civilization looking outward, but the stars that could answer us have already gone quiet, or the ones that will become active are still millions of years away. On a universal timescale, our presence may be too brief to overlap meaningfully with other civilizations. Second, there's a possibility that we are looking in the wrong way. Our searches focus on certain frequencies, signals, and methods that make sense to us, but aliens may communicate differently, using technologies or dimensions we haven't yet conceived. Signals could be present, but we lack the instruments or perspective to detect them. The universe may not be silent, only invisible to us. Third, could contact already be happening but misunderstood? Kaku notes that while there is no confirmed evidence, humans often misinterpret phenomena in ambiguous ways. Natural cosmic signals, atmospheric anomalies, and other unexplained events may be perceived as alien without being verifiable. This creates a gray area where curiosity and speculation collide, but scientific caution prevents jumping to conclusions. It's a reminder that even if alien activity exists, our ability to recognize it is limited. This tension is amplified by the ongoing UFO-UAP debates. Kaku treats these phenomena with cautious openness. While many sightings are mundane or misidentified, some remain unexplained. He does not endorse extraterrestrial visitation claims, but emphasizes the importance of asking careful, skeptical questions. What looks mysterious may be real, just not in the way popular imagination expects. Visualizing this tension helps us feel the cosmic scale of uncertainty. Picture radio telescopes scanning the void, static on the screen, faint signals flickering and vanishing. Pulses appear for milliseconds before disappearing. This represents the unanswered questions of the universe, signals that could be communication, natural events, or nothing at all. Each flicker is a reminder that the universe is vast and our understanding is still tiny. The underlying message, the mystery remains unsolved, and it may stay that way for a long time. Distance, time, priorities, survival, and deliberate caution all conspire to keep civilizations separated. Yet, the very act of asking these questions is meaningful. Kaku reminds us that uncertainty is a powerful tool for curiosity and scientific inquiry. It challenges assumptions, forces humility, and encourages us to keep looking even when answers are elusive. In the end, the tension is what makes the search compelling. It keeps us gazing at the stars, scanning the skies, and asking questions that may take generations to answer. The universe may be silent, but it is not meaningless. Its silence itself is part of the story, a cosmic canvas against which life, intelligence, and curiosity are painted. After exploring the vast distances, fleeting cosmic windows, inward-focused intelligence, protective civilizations, and the fragility of technological species, we arrive at a sobering conclusion. Alien contact might never happen. Michio Kaku frames this not as a defeat, but as a profound insight into our place in the cosmos. The universe may be alive with intelligence, but it is largely unreachable. Civilizations may exist in isolation, time may separate us from others, and physics itself imposes unyielding limits. The stars above may be teeming with life, yet our chances of greeting another species face to face or across radio waves are vanishingly small. This realization forces a shift in perspective. If the universe is largely silent, what does that make humanity? It makes us rare, perhaps one of the few species in the galaxy capable of self-awareness, technological innovation, and reflection on our cosmic environment. It makes us precious, a small beacon of life and intelligence floating in a dark and immense universe. And it makes us responsible, because the very fragility that limits alien civilizations also applies to us. Our survival is not guaranteed, and our stewardship of Earth and technology becomes a moral imperative. Kaku emphasizes a crucial lesson. Survival is far more important than discovery. While we dream of interstellar travel and contact with alien civilizations, we must first ensure that humanity endures. The universe will not bend to our curiosity. It will not pause while we perfect our technology or expand across the stars. If we fail to navigate our own existential risks, nuclear conflict, climate change, artificial intelligence, mismanagement, the question of alien life becomes moot. Survival is the precondition for any future encounter with the cosmos. In this light, our exploration of space and search for extraterrestrial life takes on a deeper meaning. The goal is no longer simply to meet aliens or confirm that life exists elsewhere. The goal is to become a civilization that lasts, a species capable of enduring the cosmic tests of time, distance, and self-inflicted hazards. Kaku's perspective transforms the Fermi paradox from a puzzle of absence into a mirror reflecting our responsibilities and potential. The philosophical takeaway is both humbling and inspiring. Humanity exists at a rare moment in space and time, equipped with curiosity, intelligence, and technology, but also burdened with choices. How we manage our civilization, how we treat our planet, and how we navigate existential risks will determine whether we remain a fleeting spark or become a lasting light in the universe. So perhaps the real test isn't whether we meet aliens. Perhaps the test is whether we survive long enough to evolve into a civilization capable of enduring the universe itself. Whether we make it to the stars or remain confined to our small planet, the challenge is to become a species that lasts, a beacon that can one day look back and understand that the silence of the cosmos was not an emptiness, but a call to responsibility. Visualizing this, imagine Earth alone in space, a fragile blue dot surrounded by the infinite dark. The planets drift, the stars shine, and soft cosmic sounds underscore our solitude. Against this vastness, humanity's existence is both fragile and miraculous, a reminder that life itself is extraordinary. Even if we never encounter another intelligent species, the act of enduring, observing, and questioning is itself a cosmic achievement. In the end, Kaku's message resonates clearly. The universe may be unreachable. Alien contact may never occur. But our opportunity and our responsibility is here, now, to survive, to learn, and to continue. To ensure that the spark of humanity is not just a fleeting moment, but a lasting presence in the cosmos. And perhaps that is the true meaning of cosmic exploration, not to meet the aliens, but to become one that lasts. As we close this journey through distance, time, intelligence, and the fragile nature of civilizations, it's time to pause and reflect. Do you think alien contact is impossible, constrained by physics, timing, and survival? Or is it inevitable, waiting for the right moment or the right civilization to reach out? The truth may be stranger and more complex than either option. We'd love to hear your thoughts, and we encourage skepticism. Question assumptions, challenge expectations, and consider the universe not just as we imagine it, but as it actually is. Leave your ideas in the comments, and let's explore these questions together. And if this video sparked your curiosity, stay tuned. In upcoming episodes, we'll dive deeper into the Fermi paradox, investigate lingering questions around moon landing controversies, and examine the latest developments in UAP and UFO disclosure. The cosmos is vast, mysterious, and full of questions that may never be fully answered, but that's what makes the search so compelling. Remember, the journey isn't just about finding aliens. It's about asking the right questions, testing assumptions, and embracing the wonder and uncertainty of the universe. The stars are waiting. What will your perspective be?